All right, so where are we? We started here. Nothing is certain, therefore something must be certain. We went through a few slides. Let's see if we can move on to where we need to be. And here we are. So we want to argue towards a conclusion, and we need to start with some premises. You start with premises, you build from premises towards conclusion. And here's an argument, an example of an argument. So all men are mortal. Here's a premise. Socrates is a man. Another premise. Therefore, Socrates is mortal. Here's your argument that is logically valid. Conclusion follows from the premises. Assuming that premises are true, the conclusion will also be true. All right. This is one of the many syllogisms that are available. We won't actually study all of the single possible syllogisms, all of them, but here's an example of one. And as we move through the semester, you're going to run into more of those, and then hopefully by the end of the semester, you'll be familiar with these ideas. So what kinds of reasoning that can be used to argue for a certain position? Well, here's the deductive reasoning. And deductive reasoning can give certainty. An example is all women are mortal. Cleopatra is a woman. That's Cleopatra is immortal, same as before. But what happens here is you move from universals to particulars. So you start with a general statement, such as all women are mortal. That's a general statement. Then you move into the particular case, Cleopatra, and from the general premise, you draw a particular conclusion. And deductive arguments can give you certainty, assuming that they're valid and that the premises are true. Inductive reasoning is different. You move from particulars to universals. So you have a small set of data, and from that small set of data, you extrapolate general principles. For example, 3 swans that I saw were white. Therefore, all swans are white. Right? So I have a small data set. From that small data set, I extrapolate conclusion that is more general. So it's kind of a reverse. Inductive reasoning is reverse of deductive reasoning. Strong inductive, the one I gave you there, an example was that was an example of a weak inductive argument. Right? Now, an example of a strong inductive argument would go like this: I have seen thousands of swans, and all of them were always white. Therefore, all swans are white. That's a much stronger argument because the data from which I extrapolate my conclusion is much bigger, much more significant. Now, obviously, I think it is clear enough here to see that the inductive reasoning doesn't necessarily give you certainty. All right, sciences heavily rely on inductive reasoning, because in sciences what we do is we collect data, and then from the data we extrapolate our conclusions. And well, that's a form of inductive reasoning, and all inductive reasoning is subject to a potential flaw, which is, well, it doesn't give you certainty. Inductive reasoning does not give you certainty. Deductive reasoning can, because in the deductive reasoning you move from universals to particulars, assuming your universal statements are true, and you don't commit any logical fallacies. You end up at truth in the end. With inductive reasoning, you only get probable results, and that may be very likely, but still, probability is probability. Okay, it's important for you to know the distinction between deductive and inductive arguments, deductive and inductive reasoning. There's also abductive reasoning, which we won't use much in this class, but you need to be aware of it. Here are 3 examples. I'll read the second one. What happens here is you look at the circumstances, and from the circumstances, you move towards a probable conclusion. So, second case, the doctor hears a patient's symptoms, including this and this and that, and from these symptoms, the doctor concludes or abduces to the best explanation that the patient is probably an asthma sufferer. Then in the third one, maybe, a while ago, Bob told his friend Larry he is going to marry Joanne. Today, Bob is showing Larry a big diamond he just bought. Larry concludes from the circumstances that Bob is about to propose. Now, conclusion here does not necessarily follow, right? It may be that whatever you abduce is actually wrong, but so that's another form of that. This is another abductive reasoning, is another type of reasoning. Analogies. very important to be aware of the fact that analogies are comparisons, and as such, they never prove anything. If you argue for a position using an analogy, that's good, because that helps you to clarify the point you wish to convey. But analogies can never prove anything. So those who use analogies as arguments can commit to fallacies, not having sufficiently strong resemblance in the analogy, and then assuming that analogies actually prove something. They don't. Analogies don't prove anything, but analogies are very useful. Teachers use analogies all the time to explain abstract concepts. Explaining a joke is like dissecting a frog. You make a comparison there. That's what analogies do. They compare A to B to make sure that B is easier to understand, assuming that A is already easy to understand. And here's another one that's as useful as rearranging deck chairs on the Titanic, and then so on and so forth. Analogies. Okay, when you do your presentations at some point, and when you do the debates, you will want to make sure that you use analogies in your debates, because they're useful, they're convincing. So let's keep going. Let's see what we have. All right, so kinds of reasoning. Deductive reasoning. If valid, gives logical certainty, assuming that the premises from which you start the general statements are true. Inductive arguments. These are probable arguments, so they will never give you certainty. Which is interesting, because a lot of arguments, a lot of reasoning in science is precisely that. It's inductive reasoning. And then we have abductive arguments, just mentioned a second ago, also give probable results. We have analogies. They don't prove anything. They're useful at explaining concepts. All right, so that's the basics. We'll try to delve a little deeper into deductive arguments. We'll see how far I want to go with this in this presentation. So deductive arguments that are sound give certainty. Now, in order for a deductive argument to be sound, all terms must be clear and unambiguous. The premises must be true. If the premises are untrue, then who knows if the conclusion is actually true or not. So the premises must be true. You have to start from truth to arrive at truth. Unless you arrive at truth accidentally. I suppose that may happen. But if you don't want to get there accidentally, but out of necessity from the structure of the argument, you would want to make sure that your premises are true as well. So the premises have to be true. Argument must be logically valid. So three things. The terms must be clear and unambiguous. Whomever you want to convince with the argument has to understand what you're writing, what you're arguing for. The premises must be true, and the argument itself must be logically valid. Oh, what was it? Right. Okay. So let's focus on the terms. You want to make sure that the terms are unambiguous. Here's an example. Nothing is more expensive than diamonds, but paper is more expensive than nothing. Therefore, paper is more expensive than diamonds. Here's an argument. There's an argument. The argument is well structured, but there's a problem. There's a problem with a certain specific word. You should pause and you should think about this. What is wrong with the above argument? Where does it go wrong? Obviously, paper is not more expensive than diamonds, right? So where does the argument go wrong? I'm going to assume that you have paused already and you have thought about this. Here, nothing is meant in two different ways. In the first case, let me see if I actually have this. I don't have this spelled out. Okay. In the first case, nothing refers to no thing, no object, no being. And in the second case, where it says paper is more expensive than nothing, that refers to like non-being as opposed to no being. There's a difference there. So nothing in these two sentences is meant in two different ways. That's confusion of terms. The argument falls apart. It's not logically valid. So there is an exercise that you would want to do now, and this presentation goes with a worksheet on logic. It's the first worksheet that you have in this unit. You should open that up and then go to the page that has this stuff: univocal, equivocal, and analogical terms. And then you're going to see there that there's a whole list of things like I love ice cream and I love you too. Two customers paid $200 each, and so on and so forth. But you should get to the point, to the page, whatever the page that is, where you have these univocal, equivocal, and analogical terms. And I want you to try these exercises there first, and then come back here and see if what you wrote there agrees with what I'm going to show you. So univocal terms, these have only one meaning. Number two is only two. There's no other meaning attached to two than two. Calculator has only one meaning. Calculator is a calculator. There's no other meaning attached to it. Electron has only one meaning. There is no other meaning attached to the word electron. Equivocal terms, these have two or more distinct meanings. So for example, a bank. The word bank could be understood as a financial institution or a river bank, right? So bank could mean two entirely distinct things. If that is the case, then the word bank could be equivocated, right? Bank could mean this or it could mean that, and the two things are entirely distinct. You could equivocate if you use the word bank into in different contexts. Analogical terms. So these have two or more meanings that are partly the same and partly distinct, right? An example is I love my wife versus I love arts. So the way I love my wife is different than the way I love arts. I love both, but it should be clear enough that the love of a spouse is different than the love of arts, yet there is some sort of an overlap. So these two terms would be used here analogically. Okay, and so what you are to do is to classify each of the terms as either univocal, equivocal, or analogical. Now, pay close attention to this. It should be easy to determine when a term is used univocally. Sometimes it may not be easy to determine whether the term is used equivocally or analogically. So when you do these exercises and then you compare them with what I have here in these slides, you may find that you have answered them a bit differently than what I have done here, and that's okay. It might not be a very clear cut as far as whether a term is used equivocally or analogically. So keep that in mind. As far as univocal terms, that should be pretty straightforward. So first problem, I love ice cream and I love you too. So the word love, is it used univocally, equivocally, or analogically? Again, you should pause the video and you should go and do the exercises and then come back to the video and see if what you wrote there agrees with what you're going to see here. Though remember that there may be some disagreement about equivocation versus analogical terms. So anyways, for this one here, this would be analogical. There is enough of similarity between the two terms within this context here to say that this term love is used analogically. Two customers paid $200 each for 2 chairs 2 days ago. Word two has only one meaning, and that is two. This is used univocally. All right, after I digest this logic unit, I am going to digest my dinner. Certainly these two terms are not used univocally, that's for sure. So the question is whether this is used equivocally or analogically. I put analogical. There is a certain similarity between digesting a unit on logic and digesting dinner. Seems, yeah, these two, this would be closer to analogical than equivocation, where equivocation is totally distinct. Macbeth murdered Banquo, yet he didn't murder the English language as you do. Interesting. So analogical, though you could probably make an argument here that this would be equivocation, where these two terms are used equivocally. So if you put equivocal for this, that would be, I think, acceptable. Although to me, it seems a little more like analogical. Water is denser than air, and air is fresh today. I'd say this is pretty clear cut. Univocation. All right, next one. I will air my opinions after I air this room. Well, analogical. Yeah, I think this one is closer to analogical than equivocation. You could probably make an argument for equivocation, but remember, equivocation has to be pretty clearly distinct. The two terms have to have pretty clearly distinct meanings, but there's an overlap here in what these two mean. So I would say this is analogical. What else do we have? All right, the candidate who is running for governor was running after a bus. Analogical. There's some overlap, although this one seems to come at least close to equivocation. All right, next one. With my hands, I changed the hands of the clock. Yep, equivocation. My hand is different than the hand of the clock. Two distinct meanings here. You could, if you really wanted to, try to say that my hand can point towards things, and a hand and a clock points also towards numbers. So you could say that there is an overlap there between the terms, but so it wouldn't be I don't think you'd get points, I think, if you were to say that this is analogical. But it seems to me that this is closer to equivocation. Poetry is an art, and painting is also an art. Univocal. So anyways, I'm going to show you the answers to these here. You may disagree a bit about whether something is an equivocation or analogical, and that's fine. And then I'll try to squeeze in a few more slides. So deaf is a great change. That's an interesting one, actually, but wish we could discuss this in class. But anyways, deaf is a great change, and it would be no surprise if a man were unprepared for it. Nonsense. Throughout his life, man experiences change every day. So your answer to this is going to depend on how you define change and what you understand by deaf. So you could put that this change here is used in an equivocal sense, because many changes, you could make an argument that many changes that happen throughout life are of a different category than the change of dying. In one case, you change a shirt, you change a shoe, you cut your hair, and so on and so forth. In another case, you stop existing, you stop being. The difference is so drastic, so dramatic that there's no analogy between them. You could make that argument, and then you would put equivocation here. But I think you could also run towards analogical meaning of the two terms. Depends on how you define change and what you would consider deaf to be. All right, for a person to be is to be happy. No univocation, that's for sure. Is it equivocation, or are these two used analogically? So first, to be is to exist. Second, to be is to feel. Now, to be isn't entirely distinct from to feel. Well, anyways, there's a significant difference there, where you could certainly state that this is an equivocation. At the same time, could you make an argument that there's some analogy here between the two? Sure, because there's certain overlap between existing and feeling, at least in a sense that if you feel something, then you also exist. If you exist, that does not imply that you feel something, right? Stones exist, but stones don't feel anything, or so we assume. Be it as it may, I put equivocation here, but if you wanted to, you could make an argument towards analogical. And what else do we have? All right, exercise: true versus untrue premises. All right, so watch out for equivocation, because that if you do use equivocation in your arguments, you will end up making your arguments just bad. They won't be logically valid. So you want to aim for clarity of terms. The next thing is the premises. You want to make sure that you start with true premises, or at least premises that are reasonable. All right, so let's run through this exercise here, where you have to determine whether premises are true or untrue. All of the following may be used as premises and arguments. Determine if these are true or untrue. And this would be fun to discuss in class, because some of these things are, well, interesting. So let's maybe do a few of these, and then I'll stop, and we'll leave this for the class where we can actually discuss it. So 1 + 1. Could you use this as a premise? And would this premise be? Yes, you can use this as a premise. But would this premise be true or untrue? Um, 1 + 1 is 2 is true. I mean, yeah. It's just true. Now, the second one, all people seek happiness. That's an interesting one. That's a very interesting one. This, we will come back to this when we study ethics. There's no one here for me to discuss this with, so I'm not sure how far I want to take this. But so this comes from Aristotle. Aristotle made the statement that all people by nature seek happiness, or all people by nature. Oh, I forget his words exactly, but anyways, it comes down to this. I'll leave it at that. And day always follows night. Maybe. What if one day it's just tonight and no day shows up? It's conceivable, it's possible. Something could happen to the sun, maybe. In any event, pigs are a species of birds. So this would be an untrue premise. Something cannot come from absolutely nothing. This is true. This is true. It's not possible for something to come from nothing. That is a metaphysical impossibility. It's just not going to happen. Now, sometimes in physics, physicists will make the claim that something can come from nothing. But what they mean by nothing is not absolutely nothing. So, for example, a case in point is in a vacuum, in empty space, right? In empty space, what's an empty space? We would say there's nothing in empty space. And a quantum physicist would make the claim that in empty space, there are particles that pop in and out of existence all the time. And that's true. But that actually is misworded, I should say. Because what's happening there is that there's really not enough, there's not nothing in empty space. There is actually something there. The empty space is filled with stuff and booming with activity. So there's not nothing there. There's a underlying quantum reality pervading all of empty space, and it is within this quantum reality, the fields that are persistent there, quantum fields that are present everywhere. It's out of these fields that particles arise. So if you take the field and you make the field behave in a certain way, that which has properties of a particle arises, and then it sort of dissolves. So it's not that these particles pop in out of existence out of nothing. No, there's an underlying structure there from which these particles arise. Something cannot come from absolutely nothing. It's just not, that's not possible. Because if that were to happen, then it just violates one of the basic principles of logic. So keep this in mind. All right, keep this in mind. This would be true. No thing can move itself from non-existence to existence. This one is also true, because if it were not to be true, if it was possible from something to move itself from non-existence to existence, then it would have to be prior to itself. But nothing can be prior to itself, right? I can be present to myself, but I cannot be prior to myself. That's just logically not possible. So no thing can move itself from non-existence to existence is true. Similar to 5 and 6 are kind of 5 and 6 are kind of similar, not the same, but similar. No thing can cause itself to exist. So if you equate 6 with 7, then 7 is true. If by 7 you mean that which is stated in 6, then 7 is true. Nothing can cause itself to exist, because then it would be prior to itself, and nothing can be prior to itself, because then it already exists, but somehow it would have to be prior to itself. It's a self-contradiction. So if 6 stands, then 7 stands, assuming that by 7 you understand what you understand by 6. All right, 8. Multiple objects of the same kind can be distinguished if there's some differentiating feature between them. I'm going to stop here. You can think about this one, but I'm going to stop here. Because we should have, this makes more sense if we can have a discussion, but something for you to think about. So I'm going to pause here, and this will do for this presentation.